Welcome to Emerald Hill Skies. My name's Doug Lucas and we're coming to you tonight from the outskirts of Louisville, Kentucky on a night that's got some degree of cloudiness up in the sky. It had been forecasted that we were going to be absolutely clear, but we'll see how we do. Just ran the focusing routine, Hocus Focus in Nina, and the first couple times I ran it, we couldn't get focus, and I looked at the sky view. Let's see, I'll let you guys look, and sure enough you can see some clouds there that were wafting by, and I guess they were right in the middle of some of the stars that our focus routine was counting on. Looks a little better now though, huh? Looks like it is clearing. Let's see if we can get our monitor going here so we can see what you guys are seeing. Let's see. Let me make sure that I can get that audio going to, gonna try to tune in. What I do here on the side with this monitor is basically I try to look at the very same thing you guys are looking at, so I kind of see what you're seeing, and okay, looks like that's working. Dark Meta, good to have you here. Pier-Tech, welcome. Glad to have you here as well, Vito. Tonight, we're actually beginning with a new catalog you might have seen, and it's the catalog that corresponds to this, Hidden Treasures by Steve O'Meara. Steve is the author of the books that we've done on Caldwell List, and also the Herschel 400, and now this thing called Hidden Treasures. So we're looking forward to being able to see what Steve has to say about these. Let's get started. Let's get rolling. So let's see, I guess the first thing we ought to do is come here to the screen and take a look at our first target. Let's kind of run things again. These are in no particular order. This first thing is the PK8403.1, commonly called the Green Rectangle. It's NGC 7027, a planetary nebula. So let's connect to our telescope. There we go. And see if it's connected. Etienne, good to have you from Ottawa. Or maybe it's from Montreal, come to think of it. Outside Montreal, I think. For some reason, our telescope is not connecting. Hello, Jen, welcome. Glad to have you here. For some reason, our telescope is not connecting, so we might have to, oh, I wonder, no. Might have to actually shut this down and open it again. Let's try that. Let's shut down our Deep Sky Planner 8 software. It is not having a good time connecting to our scope. Our scope does look connected. Oh, it's not tracking. That's one problem. I wonder if that's been the problem. Close enough, Etienne says. Montreal, I think. Yeah, you know what we're going to do? We are going to open up the task manager, I guess, the dreaded task manager, and kind of force shut down our Deep Sky Planner. Let's do it. Let's bring up the task manager and find Deep Sky Planner in the list. It is right there. And let's end task on that. For some reason, it was not happy. So we're going to start it again now. This is our targeting software and also the software used for observations. And let's connect the telescope first this time. Connect. Still not happy. Huh. What do you guys make of this? Okay, so you know, along with the line of what can possibly go wrong, let's figure out. Tracking's enable. Sync time from PC. That could have been an issue, perhaps. Who knows? Boy, once again, it's just not connecting. Oh. Well, I suppose if worse comes to worse, we could use... Hello, Stu. Good to have you back. From down in New Zealand. Stu, we're currently trying to connect our targeting software to our telescope. And all we're getting here is some hourglassing. So I guess if worse comes to worse, we could point to the targets with the way we used to do, with our planetarium software. Good idea, Stu. Go grab that coffee. It'll be just a second. We're getting hourglassing here. Dark Meta says, sup, Stu. Yeah, let's go back to our task manager again and force close Deep Sky Planner. In task, and let's see. Let's try it one more time, just because it's so much better. Let's go on telescope. Let's go to setup first. That is the right. All settings have been moved. Looks like it is aware of our proper. The mount, in other words. It is aware that the mount is there. So let's try one more time to connect. Give it a second to think. What else could it be? We know that the scope up here in the upper right, see, we can see that the scope is alive. It has been zeroed properly. Time has been set properly. All these things look okay. It is tracking. But for some reason tonight, the targeting software won't look at it. Sadness. This will introduce an extra element in our workflow. We have about 18 people on so far. We're trying to connect our targeting software. Etienne says, Stu to the rescue. Yep. At least Stu's going to go make coffee. I can't imagine what might be going wrong. I tell you what, just to check things, let's go to our imaging software and see if it'll connect to the mount. It's not connecting either. Okay, so there must be something wrong in River City here. Well, at least you get to be a part of what sometimes goes on in astronomy, and that is troubleshooting, you know, with the phrase, what could possibly go wrong? We're going to go with Control-Alt-Delete again. We're going to go back to Task Manager and force that Deep Sky Planner to close, end task, and we're going to, let's see, what else attached to the mount at this point? Nothing. Oh, no, it's still not connecting there either. So it must be aliens. Jen says that's stubborn planet Mercury. Let's do this. Let's close the mount software. And now let's open it again. Okay, so it did connect correctly. Let's say set current position 0 position. Sync the time from the PC. Start tracking. Now let's see if we can connect to it. Ah, that connected. Now let's go to Deep Sky Planner and telescope control, connect. Oh, there it goes. So I guess what we can learn from this is that if ever something doesn't go well, close down the mount software and then restart it. And I could see possibly why that might have happened, because I did have a problem tonight connecting the primary imaging camera. And in order to correct it, I did have to turn the mount off in the observatory. Oh my goodness. JM just gave coffee for technical difficulties and said you're appreciated. Thank you so much, JM. That reminds me, you guys were kind enough to give a bunch of funding last month. And I told you it was going to go for Ukrainian refugees. I'm going to cover up the bank number here and show you. Here is the check. Here is the check that we've written out. You can see down there in the lower corner that we've written this check out for Ukraine. And look at the amount, $461.73. So I am standing good on my promise. You guys were kind enough to be generous, and we're going to in turn pass along your generosity. All right, let's run this and stow that down there kind of out of the way. Go back here to the screen. Okay, we're finally set. By the way, JM, thank you so much for pitching that in. That's so kind of you. Mike, good to have you aboard. Georgia. Berkiti son los gremlins. Entonces Berkiti habla español, parece. Hidden gremlins, right. Dark matter, Georgia. Oh, yeah. All right, ready to go. Let's run this one more time. And it looks like the first target now is Melot 215. It's a globular cluster. That'll be a good one to start with. So let's slew to that. And there's a view of the scope as it starts to turn in the direction of Melot 215. It's also known as NGC 6712. So we're going to go up here in Sharp Cap, NGC 6712. And looks like we're still, look at the weights. The weights have gone to the west. Remember, left is west. And the scope is looking pretty much straight up toward the zenith almost, a little bit toward the west. Let's put our title here. This is NGC 6712, a globular cluster in what constellation? Can't see the constellations. Let me pull this out a little bit farther. SCT. What is SCT? Scutum or something like that? Scutum, right? Scutum. We'll put that right now and we'll come back and change it if it's not right. All right. So this is the beautiful part of the sky. Look at all those stars. Let's go up here at the top, and remember we've got a new sequencer routine going. And what it does is it does both ends of our automation. We used to do manual plate solve when we arrived on a target, and now it asks us for the name of the target. We already had that filled in, NGC 6712, and then it does our first plate solve. So you know what a plate solve is, remember, those of you that have been around. Oh my goodness, Pier-Tech, thank you so much. $49.99, and there's a picture of a transformer over there to the right. Vito, thank you very much. You guys will recall that Pier-Tech is the one who designed and manufactured the observatory that we're using. It's the Pier-Tech Tele-Station 2 observatory with a roll-off roof. And they also, Pier-Tech designed and manufactured the adjustable-height pier that's there in the middle that you see the mount is fastened to with the weights and everything. And we can raise that up, and you can see how it puts the telescope up above the wall of the observatory, so we can see down to, like, I don't know, 8 degrees above the horizon, pretty much at all 360 around. That's all Pier-Tech stuff. So thank you, Pier-Tech, for designing and manufacturing a quality observatory. Now, we did pay for this. Pier-Tech, I want you to know, Pier-Tech didn't give us this, and so I don't tell you that we love it because Pier-Tech somehow gifted the observatory to us. We paid for it. And they did give us a little discount, but it's the same discount you can get if you buy those two together, the pier and the observatory. You can get the very same discount we did, and we love this. It's been just absolutely stellar in every way. So can't say enough good stuff. Jen, what in the world? Jen's also given 20. Thank you so much. Baux1, good to have you from Melbourne. JM from the Ozarks. Azray, good to have you aboard from Arizona. JM is saying thanks to Pier-Tech. And Stu, as sponsored by Pier-Tech, right. Mike is saying, yay, Pier-Tech. Woohoo! All right, so we did plate solve. And you notice that after it plate solved, it liked what it saw. And it started our live stacking for us. That means if I get to talking to you, we're already live stacking, so we don't waste that time like we used to. And it does the first color balance for us. And now we'll pull these blacks over here to a really good color balance, by the way. Put those blacks right about there. We'll pump up these mids a little bit. And there you can see in the middle of the frame, we're starting to see this globular cluster. That's at about 100%. It's a beautiful little cluster, and it actually has a really neat greenish yellowish tinge to it. And let's see if we can look this up now while that's accumulating, just a couple of minutes. And in our upper right on this book, I like it that the numbers are giant, and it's so much easier to find than the Herschel 400 book. This is, however, we don't have his in our targeting software. It doesn't tell us what the number is. Like, you know, in his list, it's called like X such and such. So unfortunately, we're still going to have to look back in the index, sadly. Let's see, so this is NGC 6712. NGC 6712. It's Hidden Treasures number 95. Now at least we can turn right to 95. And sure enough, in the upper right there, it's Hidden Treasure 95. NGC 6712's got a nice map there to locate it, and a lot of stuff that's telling us about the object. So let's read about it here. This is a globular cluster in Scutum, so that's the correct name. Scutum along the floor. It's one of those fill-in-the-blank constellations, Scutum is. He talks about he says, NGC 6712 is a relatively small, and it's 67 light years away. Very good. About 1 million suns. Wow. 1 million suns in this globular cluster. It's located in our galaxy's halo about 11,400 light years from the galactic center. Still, images of the cluster's core with the European Southern Observatory's very large telescope in Cerro Paranal in Chile reveal a blizzard of starlight. I like that. In the outer envelope, where stars seem to be slowly dissolving, losing fainter, lower mass stars into our galaxy's halo. Francesco Parese, he's in the European Southern Observatory, notes that none of NGC 6712 stars are less massive than the Sun, making it totally unlike any globular cluster surveyed by the Hubble Space Telescope. So none are less massive than our Sun. Most likely it's unique only because no other globular cluster comes as close to the Milky Way center as does NGC 6712. That makes sense. The massive, supermassive black hole in the middle of our galaxy is robbing stars from this globular cluster. It's thought to have crossed through the crowded galactic plane only a few million years ago, just a few million years ago. Each passage not only robs low-mass stars from the cluster because they tend to lie at the cluster's periphery, but also stretches out the cluster like a comet's tail. Okay, and we've got 5 minutes. It's visible as a pale glow in binoculars. It does have a good field of view in his 4-inch refractor. It's compact. The core screws in and with a direct gaze looks irregularly round. The outer halo is speckled. Boy, he writes a lot about each object. I like this. There's a hollow surrounded by arcs of dense clumps of starlight. 2 bright arms forming a V. Yeah, you can see that V, I hope. Let's zoom in a little bit more just so you can see a little more of that structure. So now we're kind of getting into a little more of the digital zoom. Condensed at the core. So this is, how far did we say? What was the distance again? Distance, 22,500 light years. 22,500. So now we're going to go over here and we're going to say observations. We have to do our session for tonight because this is our first observation. And we're going to end on the 26th. And let's just give us until something like 2, and I forget what this is. Something like session 87, something like that. And down here in the notes we'll say NGC 6712 is X95. The reason why Stephen James O'Meara used X for the abbreviation, you know how we have Messier uses M, Caldwell uses C, Herschel used H. Stephen O'Meara used X because his list is called Hidden Treasures, and he kept joking, X marks the spot. So that's why he used X. Is X95 about 22,500 light years away? Near neighbors. Jen said that it sparkled like Christmas. 1,000,000 suns. Fantastic. We'll do a picture of this. Now, what we do now, I can't remember if I've made it so it goes back to auto. So I'm going to go back to auto here. And on the sequencer, I think we run this again. Yeah. And now we go down here and we run this again, refresh that list. We go up to the top and we go to the next one, which is a double star. So this should be quick stop. It's at Hipparchus 87937. So we're going to slew to Hipparchus 87937. So I'm not going to fill it in yet. I'm going to go ahead and put Hipparchus 87937. 87937. And wonder if we've finished slewing there. We'll find out in a second. Let me see what you guys are saying in the meantime. JM Funfetti Cluster, right? So this is a double star, and you might be wondering, why would Stephen James O'Meara have us look, we were off 0.15 degrees. Why would Stephen James O'Meara have us look at a double star? Well, the point is that Stephen James O'Meara intentionally picked things that were overlooked by other lists. So he wanted to get stuff that wasn't in the Messier list, you know, Charles Messier, the Comet Hunter. He wanted to get things that they weren't in the Caldwell list, Sir Patrick Moore's list in 1995. That was like another 110 objects that Messier hadn't listed in his catalog, and that makes up the Caldwell catalog. So what Stephen James O'Meara said is he's going to go with 109 objects that are outside of those two things. And so he chose a list that had an assortment of every kind of object that maybe an amateur astronomer might look at. Now here, the thing is, we don't know which this is. Let's try using this deep sky annotation. 87937. Yeah, that's it for sure. You know, it's also called Bernard Star. Hipparchus 87937, Bernard Star. So it's right there in the middle. Everybody remember where that is. It's kind of at the end of a V. And let's zoom in on that. Well, that's at 100%. Well, there is a very, 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 very faint star there beside it. And this is supposed to be Hipparchus 87937. Do you think Stephen James O'Meara listed that in his index under the name Hipparchus? Do you think he would have done that? Hipparchus. He didn't. Now we're in trouble. How do we look this up even? CCDM maybe? CCDM. He didn't. Let's look up double stars. This is definitely taking us an extra step. How do we find this? Stu, how are we going to find Hipparchus 87937? Oh, we know it's called Bernard Star. Yep, sure enough, it's Hidden Treasure 87. It's kind of a hassle. I'll have to transfer all these names into our Deep Sky Planner list somehow, won't I? So that we just can go directly to this. Let's go back to the screen. Oh, you know what else I need to change? Bernard Star in our title. This is Barnard's Star. It's Hipparchus 87937. A double star in Ophiuchus. I forget how to spell that. Ophiuchus. Ophiuchus. How do you spell that? Oh. I'm going to take a wild guess. Ophiuchus. But somebody correct me, please, if that's not the correct... Ophiuchus. Somebody correct me, please, if that's not the correct spelling. All I have here is the abbreviation. Black flags of dark nebulae. Barnard was a virtual Blackbeard when it came to astronomical discovery, meaning the man was a living legend. In Captain Johnson's General History of the Pirates, Blackbeard is described in celestial terms as a man who frightened America more than any comet that had ever appeared. While Barnard wasn't likely to frighten anyone, his name is attached to 14 of these horrifying apparitions. What? But it's the sheer number and magnitude of Barnard's other discoveries that really sends a shiver up the spine. Barnard's name is associated with almost every type of D-sky object visible in the sky today. There's a dwarf galaxy, another galaxy, a loop. He tells all the different things that Barnard found. He did 4,000 photographic plates of the Milky Way. He wrote books. He imaged Pluto before Clyde Tombaugh actually gave it a name and discovered it as a planet. But there's one outstanding discovery by Barnard, commonly neglected by visual observers, a rapidly moving star in the constellation Ophiuchus. O-P-H-I-U-C-H-U-S, good. Known as Barnard's runaway star, or simply Barnard star. It's funny that many mid-northern hemisphere observers lament the fact that unless they travel, they cannot see the closest star system to our sun, Alpha Centauri. It's funny because they have the second closest star to our sun after the Alpha Centauri system with an easy visual grasp, lying just 6 light years. So this star, which is apparently right here, I'm guessing. Can you guys see that? Can you guys see my little pointer? That star is just 6 light years away. This is like, we can travel to this before our life is done, perhaps. No, unlikely. It's equivalent to the apparent diameter of Venus at full phase. In other words, if your telescope can resolve the disk of Venus, you can follow the annual movement of Barnard's star. The star's apparent rapid motion across the sky is amplified by the fact that the star is approaching us at 140 kilometers per second. Jumping 60,000 gigawatts. This star is going to collide with us. It's a true space velocity of about 166 kilometers per second. The closest approach, 3.9 light years, occurs. Oh, it's not going to collide. It's only going to be 3.9 light years in a mere 10,000 years. At that time, the star's proper motion will have increased to 25 arc seconds per year. And its brightness will have increased 100-fold. Are you guys getting all this? 4th closest star to Earth. Whoa, that's heavy, Stu says. It's a red dwarf. It could be an old disk star. Has less than 17% of the sun's mass. Great Scott, Dark Meta says. Sure enough, that is the star, that bright one that we're looking at there. Oh wait, is it really? Maybe it's not. I'm trying to. Let's look at the map again. My goodness, the map is complicated. The V. I can't make head nor tails out of his map. Maybe it's turned. It is. So there's that, and there's that. So which one is Hipparchus, Steve O'Meara? Here's his map. See if you guys can figure this out. There's the V. But look over there at the left is the bright star. Is it that it's upside down? How do we even know which? Need some help here. Stu, need some help. Let's do this. Let's open up, let's go to our, not that. Let's go to this, that. And then let's go show chart. And then let's zoom in. And we're looking for Hipparchus 87937. Hipparchus 87937. Center. Barnard star. Wow, it's smaller than I thought. Okay, so help me out here, gang. Stu has given us some commentary. 7 to 12 billion years is considerably older than the Sun, which is 4.5 billion. It might be among the oldest stars in the Milky Way galaxy. We just need to be able to find it now. Okay, so is that the V? Is it that it's the... Let's go back here and use the deep sky annotation again. Now it's saying right there, but could it be that one maybe? In other words, right there. Is it this one? So I would say that's like in the middle of the V. If we can find the V and this bright star here, is it this one? So now let's try to go back to our planetarium software. Can anybody find the V? It's likely dim. Is that... Oh, look, there's the V, I think. So is it at the point of the top of the V? So is it that? Maybe this big arrow points to it. So this, my new theory is that our deep sky annotation is off a little bit. It's not perfect, deep sky annotation. And I'm guessing it's this. It's the Christmas star at the top of the tree. Now let's see if we can... Yeah, that makes sense, I think. Oh, I'm so sorry. Sorry, Stu. I'm thinking it's at the top of the Christmas tree. I'm thinking it's right there. Barnard star. No, I don't think that's it. Because in this picture, I now see the V. So from the Christmas star and the top of the V, we're going to star hop up to that and then star hop over. Okay, I see that. I see that line. And there's that line, and it goes down and makes that turn. There are those two stars. So I think you're right. I think it's very dim. I think it's right in here. Boy, this is harder to find than I thought it would be. There's that turn. Now in this area, it's the top of the point, JM thinks. but I'm no astronomer. It is to right and big and red. Okay, looking again at the drawing he's given us. I'm sorry this is taking us a while, gang. 66 X. Oh, X must mark the spot. Let's go back over the planetarium software. Now that we know, here's that Christmas tree, and there's the star. And then let's peek off to the right, and let's look for these 5 stars. And then let's go down to this area right here in this nice wide-based triangle. And I think it's going to be right in this area. So now let's go back over to the planetarium software and look a little closer this time. Barnard Star was studied as part of Project Daedalus between 1973 and 78. The study suggested that unmanned travel to another star system was possible with existing or near future technology. Oh my goodness! Okay, so there it is. Boy, a lot of our stars disappear, making the deep sky survey thing harder. Where is the Christmas tree? Did you guys ever have a harder time finding a star? It's because there's so many stars in this crazy sky. Okay, look, there is a bunch of stars together. Oh, look, there's the Christmas tree. See, it's just a different scale. There's the Christmas tree, and there's the top. So we want to sight along from the right of the Christmas tree. We kind of want to go. It's like the Christmas tree is looking at the star a little bit up toward this brighter star. And look, this will help us. There are 2 stars here and 2 stars there that kind of elevate it. We are going to find this, gang. So go off to the right of the Christmas tree, past a bright star, right there, in where 2 little stars and 2 little stars are looking at it. Nuclear pulsed rocket employing nuclear fusion, accelerating for 4 years, could achieve a velocity of 12% of the speed of light. The star could be reached in 50 years. Treasure hunting the stars, right. All right, has everybody got this memorized? What we're going to do, now let's go back to the real live view. Let's bring our dark sky up a little bit. Make it a little bit darker. Okay, so over here to the right, we're going to look off to this direction. Let's back off a little bit. We're going to look over to the right. We're going to kind of go up like that. And then they're going to be we're going to look off to the right a little bit in the direction of this star. Oh, look. Here are 2 stars. Here are 2, and here are 2. Here are 2, and here are 2. Or maybe not. We're going to look off to the right of the Christmas tree and kind of up. Anybody see it? Don, good to have you here. It's that dot. That's true. It's that dot. Okay, picture this Christmas tree as if it's a man or a woman. And we're going to look up a little bit in the direction of that yellow star, but then we're going to drop our gaze over here somewhere. And there will be two stars and two stars. They don't stand out as much in our real picture as they do in our... Boy, I need to get a bit of this. I need to pull this down so I can just click on it. Like maybe put it right there. Okay. So here's Barnard's star. And here's our Christmas tree. That's that brighter star. So it's gonna be pretty bright. Do you think it is that yellow star? We're gonna look past that bright and look at that bright star. And then see these two stars here that kind of point at it, sort of. But this one misses it a little bit. These two stars point at it. You think it's a bright one? Berkiti. Find our Christmas tree guy again. He's looking off in the direction. Okay, let's go back to our live view. Here's our Christmas tree guy. Ah, maybe it's that. And this is the two that's pointing at it. And that's the other two. So I'm thinking it's this. Here are the two that's pointing at it. And there are the other. Here are the two that's pointing at it. If it's the right star, there should be a bright star here and a bright star here that make like a pretty much an equilateral triangle. And that equilateral triangle should point a little bit to the right to get to that star. So we think it's that star right there. So now let's go back to our planetarium software. And our little guy is looking over this direction. He goes to here. Look, here's the equilateral triangle, so that is not the right star. Here's the equilateral triangle. That's the star I thought it was. But this is going to help us because the star I thought it was, it is between and closer to the first star. So again, here's the Christmas tree guy. He raises his gaze. From that gaze, travel that line toward the star we thought it was. Okay, let's go back here. The Christmas tree guy raises his gaze. So is it? He raises his gaze toward this star. And he looks toward this. Now we've got the conundrum of here are three stars. Is it that one? If so, there should be two stars below it that make kind of a not equilateral triangle. What do you call that? Isosceles or something? And there should be a row of four. And by the way, Barnard's looks like it's a double. And we're definitely splitting the double. Let's go back to this. Boy, it doesn't show it as a double there. look, there's a row of 3 stars, and it's off to the right of that row. What are you guys thinking? Here are 2, something C3PO would say. Four stars. It's the 3rd one in that string of 4. No. 4 stars. It looks like it's the 4th one. Look how these 2 brighter stars point right at it. No, it curves a little bit toward this star. Boy, we're in the ballpark now. Look, those are those 2 bright stars. And this does curl a little bit. I think that's it right there. Finally, the chase is over. We have Barnard's star. Yes. It's that big boy to the left. I'm moving E and E from the orientation of the tree. You think it's the big one. East-northeast. I don't know if it's the big one or not. Do you think it is? You think it's the big one? This one right here. Doesn't look too red. So here's the gaze. You think this was the one that's raised. Ah, so you think it's this one right here. In which case this would make a kind of chevron arrow to point at it. These 4 in a row would be starting to be a parade and blocking the view of that arrow. Okay, let's test your theory. Here's the Christmas. There's the Christmas tree. The Christmas tree guy is raising his gaze to the left and finding a big bright star. So you're saying that's that. Okay, I'll buy that. And then you're saying it's right there, in which case these are the 4 that point to it, and those are the... You're right! It is that big bright star. This is Barnard's star. Well, that took us 25 minutes. That's crazy. Okay, I'm going to just do an area photo of this because that was too hard to find on the big picture. I'm going to go like this. I'm going to include the Christmas tree guy. I'm going to include all of the pointers that we used. And we're going to call this Barnard's star on 2022 09/25. Now here's my question. Does this thing let you annotate? Can we write on this? I Just wonder if there's any way to write. All I want to do is mark it. Anyway, we'll forever know that it's this, right? Okay, Barnard Star. Wow. I don't think you can write in sharp cap. That'd be pretty cool if you could, wouldn't it? I don't think you can, like, annotate with anything. Sadly. Doesn't help you. The guide picture was slightly skewed from the angular telescope. Yeah, that's correct, Don. With all that work, we should rename it Doug Star. No. Barnard did the work. Why hunt for it? Just enter it in your scope and salute to it. Be center of field of view. It was supposed to be in the center. And if you look down here, I mean, look at auto. If I go back to full field, it is. That's the center of the field of view, right there. But we were just wondering which one of those multi-thousand stars is it? I guess we could use this thing here. Yeah, see, we didn't have it exactly in the center because those would be the crosshairs, and it missed the crosshairs. We think it's this star, see, so it missed the crosshairs slightly. Bummer, huh? Jim says, I concur. Okay, so now we're going to go down here and we're going to say add observation. X87, Barnard's star, was difficult for me to find. Had it not been for the patience of the 22 people watching the live stream currently, I would never have been able to find it. In fact, I didn't. It was, who was it? Stu said it's that dot. But who said it's the big dot? Dawn, maybe? Look for ice cream. It was maybe Dawn or who was it said it was the big dot? That one looks red. It's the big boy. It was JM who finally nailed it. Thanks, JM. Now let's just figure out what the fanfare is about briefly. Okay, so it's moving fast. It's a red dwarf. It's probably got at least one Jupiter-sized planet orbiting it, because there's a peculiar wobble in the star's motion. The wobble might be due to a gravitational tug-of-war between the star and the planet. Nobody's been able to verify that. Hubble has failed to reveal it. Still unknown. Look for a ruddy flame shining at magnitude 9.5. It is the middle and brightest of three stars. magnitude 9.9, formula line 20 arc minutes long. The northernmost star points to 15-minute long fishhook. Use the detailed star chart here. Boy, I sure don't get his star chart. So sorry, Stephen James O'Meara. I do not. I do not see this as helpful. I have to wonder how many of us have seen Barnard's star. Although I've been observing the sky for about half a century and have long known about Barnard's star, I didn't hunt it down until June 2003, after I'd started this project. I've never been at a star party when a telescope barker shouted out for one and all to come and see the famous runaway star. Yet how easy it is to see and how wonderfully educational it is. Once I saw it, I scolded myself for waiting so long. How much fun it would have been to track this star since childhood. Fascinating. So it's because it's so fast moving. It's famous for being so fast moving. Steve O'Meara wondered just how many people had actually tracked it down. Well, guess what, gang? Tonight, the 22 of us did. Thanks to your patience. Hey, JM gives $5. That's so nice. Thank you so much. That's awesome. In celebration of being the guy who found the star, Stu said, going to be its closest in 10,000 years. Don, FYI, JM, YouTube takes 30% of your tip. That's okay. We're not complaining about that. Let's see. Berkite, I saw it in '84 in my first astronomy lab in college. Nice, Berkite. Don says, a lot of us may have seen it, but knowing we have seen it, that's a different story. JM, I won't resent them, Don. I have not the fortitude to build my own tube. Don, JM, just wanted you to know, Don, maybe up your donations 30% to make up for it, Don says. And Stu laughed. You guys are great. All right, well, we're done with this. I like that you have soundtrack listed in the details. You're nice. All right, so we're gonna go back out to, I don't think I did this thing where it goes back out to auto. I gotta add that to the sequence. And then we're gonna say, run this thing again. And then we'll go down here and we'll hope to go to the Blue Racquetball Nebula. Is it still in view? Wouldn't we want to go to the, yeah, it's still, let's go to the Blue Racquetball Nebula. We're gonna go to the Blue Racquetball Nebula, gang. And this is the NGC 6572. NGC 6572. Looks like the telescope is settled, doesn't it? And we're going to go down here just while it's settling and say NGC 6572, the so-called Blue Racquetball. Is that really the common name of this? Blue Racquetball Nebula in Ophiuchus. Yeah, I think you're right, Mike. We should take another picture every year. Or 10. As close to the same night and time as possible. Let's all 22 of us meet back here in exactly 1 year. The object received the nicknames Blue Racquetball, Emerald Nebula, Green Nebula, and Turquoise Nebula. Turquoise Orb. Nice. Okay, now that we're here, we're going to click that OK. Norm, good idea. Then compare coordinates and see how much it moved. Don, or take a picture every night it is visible. The motion of the Earth should be great enough to make parallax show up. I like it, Don. I think that might be the blue racquetball right in the middle, but I'm not sure. We're going to find out here when we plate solve. While this is plate solving, I'll just pause long enough to say that we are using a RASA 11-inch Rowe-Ackermann-Schmidt astrograph is what that acronym stands for. Rowe-Ackermann-Schmidt astrograph. A RASA 11-inch scope. And we're using a ZWO ASI2600MC Pro camera. You can see there it's fastened onto a Octopi-Astro camera interface, which in turn connects to the corrector plate on the front end of this RASA. So that black dew shield on the end of the RASA is actually hiding the camera, so to speak. You can see it's setting on a iOptron CEM70G mount. That's the black hunk of metal that's on top of that adjustable height pier. And we have an outrigger on top of the scope with a sky cam view, so you can see this view of the sky. And that outrigger also has has a USB hub, which is the bigger box, and on top of the bigger blue box is the Pocket Power Box Micro, the Pegasus Astro Pocket Power Box Micro. And that connects down at the base of the pier to this rig rack kind of deal that houses the AC, the Triplight AC power filter for 110 on the left, and then mounted on top of that is a 12-volt power supply at the top, this little silver box. Underneath that is a Western Radio rig runner 12-volt distribution. Takes that 12 volts out of that power converter and sends it to all the different objects on the scope. And on top of that is an Icron Raven. It's the 3124 Raven that sends the data from the telescope and the cameras over fiber optic to the 200 feet away path to the warm room where I'm sitting inside of our offices here at Emerald Hills. Okay, back to our screen. We have now plate solved and we're live stacking. I'm going to move this black threshold right there and bump up the mid just a little bit and then zoom in, because this is our racquetball, and there we're at 100%. Still pretty tiny there. Oh my goodness, JM did give an extra $5 to cover the 30% loss to prior super chats. JM, you're awesome. You're awesome. Bless you, man. Tonight's, if these folks that are giving tonight, all of this money is going to go to two Afghan families that are trying to make it out of a neighboring country where they had gone to seek refuge, and that neighboring country has now kicked them out only to send them back to Afghanistan. And so JM, thanks for that encouragement about the sweet setup. Jen, thank you, JM, for covering all the 30% donations. Don, you're asking how much all this costs. My general rule of thumb is try not to add this up, so that way I don't have nightmares. So I'm not going to even guess what it costs because it's just not helpful. Dark Meta says, I think more. Stu, NGC 6572 began to shed its gases a few thousand years ago. Because of this, the material is still quite concentrated, which explains its abnormal brightness. It does look very bright, doesn't it? Wow, you can pretty much not see the central star because it's so bright. Dark Meta is still trying to guess the prices. Could he? You guys, I haven't added it up, to be honest. I just decided I wouldn't add it up. Don, the scope is likely at least however much that is. Not kind of silly question. What planet is the brightest star in the southern sky tonight? The brightest object in the southern planet would be like Jupiter, right? Dark says maybe way off. I get a lot of astro ads. JM, talk about an emerald star. Right. It's an emerald star over Emerald Hill skies. Don, lots of you buy it all separately and don't keep track. I've been there. That's exactly right, Don. Don't add this up so you don't get a complex. Stu says, yep, Jupiter for sure. So look at that. It's so bright. You're not seeing the central core. But there it is, NGC 6572, the so-called Racquetball Nebula. Now I wonder how close our deep sky annotation is to this. It's off a little bit as well. You see how that's just not a perfect world. The deep sky image annotation is just an approximation of the location. It does have a little greenish tinge, doesn't it? Okay, let's make a little time and save this exactly as seen. And let's go over and do this observation. It's so bright. Stu thought that it was bright because it only shed its material a few thousand years ago. It only shed its material a few thousand years ago. RASA 11 inch is Norm's giving the price of the RASA 11 inch. Don says Jupiter's opposition. So yeah, I think Monday is when Jupiter's opposition. It's the closest to the Earth for years. I think, in fact, the closest in 70 years. I keep getting this one ad for a $30,000 optical tube assembly. I'm like, okay, thanks. Oh, correction. Norm gives a correction for the price of the RASA. The envelope of gas is currently racing out into space at speed about 15 kilometers, 15,000, right? Is it just 15 kilometers per second? As it becomes more diffuse, it will dim. From NASA, stargazers can expect excellent views of Jupiter the entire night of Monday, September 26th. Closest in 59 years. Okay, I thought 70. All right, so we'll say couldn't make out the central star because of the brightness of the material jettisoned. Okay, so this is a planetary nebula. So again, we've talked about these before. It jettisons its material out from the outside of the disk and begins making this kind of ballooning type deal that is then lit up by the central star that has become a white dwarf. Okay, we'll save this again exactly as seen and start our next sequence. And the next target we have, run this again, is an open cluster, Colander 380, NGC 6633. So let's slew to that, NGC 6633. It's all clear tonight. Looks pretty cool as it rose. You guys are still talking about Jupiter. 367 million miles in distance at Earth, about the same distance it was in 1963. Oh wow, look at this cluster. Wow, is that not beautiful or what? My goodness, that's gorgeous, because it doesn't hurt that we're zoomed in on it. This is beautiful. Let's look this up. NGC 6633. I have a feeling that Steve O'Meara is going to say fun things about this, because it does look just like a bunch of diamonds, doesn't it? 6633. It's Hidden Treasure 92. Hidden Treasure 92. The Tweedledum Cluster, the Captain Hook Cluster, the Wasp Waste Cluster. What? And this is NGC 6633, right? Yes. So we'll say okay there. And down here we'll put our title, NGC 6633, the Tweedledum cluster. Why would they call it that? In Ophiuchus. It's beautiful. Please show us. Yeah, the difference between tonight and Monday night, 24 hours, is absolutely incremental, no difference at all. There will not be a difference between tonight and tomorrow night. So we'll look at Jupiter in a minute if you guys want to. It seems like there's a consensus to go look at it. Bright, have you seen this cluster is considered a fine object for binoculars or small telescopes. Don, also everyone, the NASA DART mission will slam its washing machine-sized impactor into an asteroid orbiting another asteroid tomorrow evening. So search for the NASA stream tomorrow. SLS will be rolled back to not come out until next year, sadly. Super excited for DART. Very curious to see what happens. JM, all those jewels. Good old NASA. Wow, this is so cool, isn't it? Where does it start and where does it stop? And why do you call it Tweedledum? Pray tell. So this is 92, X92. He gives a history of the people who found it, all the people who tried to discover it. Stands apart from the Milky Way band that includes IC4756. Its bright and concentrated core would have stood out from the rest of the Milky Way as a cluster. 4756 lie at similar distances. 4756. Anybody see another cluster here? 4756 paired with, oh, Tweedledee. Probably discovered around the time Lewis Carroll was writing. Makes you dizzy. Okay, everybody take a guess where the other cluster is. Is this Tweedledum and over here somewhere is Tweedledee or what? What do you guys think? Nearly large as the full moon, the cluster contains 38 known stars, shines at a total magnitude of 4.6. They're all about the same blue-green color. Perhaps we'll find Tweedle3 tonight. I'm guessing, is this supposed to be Tweedledee over here? Okay, we're ready to reveal it with the deep sky image annotation. Well, that's 6633. Evidently, we're not seeing 66, whatever the other one is. 93 is IC4756. Is that on our list? Yes, it should be. IC40. I don't see it here. Why isn't it right here beside it? Oh, right there it is. Yeah, you're right. Okay, so it should be right beside it. Bottom right, Beer Kitty is saying. Zoom out to full view. That is full view, isn't it? Yeah, that's full view. So you're saying down here, looks almost like a mirror image if a line is drawn down the middle of the structure, like those ink blots from back in the day. Huh. Okay, I tell you what, let's do. Let's go over to planetarium software. And let's look for NGC 6633. could have just used show it, couldn't I? Not seeing the... Oh, is it closer? Not seeing the IC4756. Let's show it. Is it in the same field of view? Okay, couldn't read it. Thanks. Very helpful, that planetarium. JM, I commented a while back that this is where those ink blots came from. You're right, Jen. Does anybody see an IC number here anywhere? Because I am not seeing it. IC. Show chart. It should have queued it up. Oh, there it is. CIC 4076 here. So they're very close. Again, 6633 is no, well, 6633. It on, so they'll both be labeled. They should both be checked. Oh, look, they're way over here, so it's outside our field of view. This should be our field of view here, and 4756 is over there. So we'll have to get these in two different glances. So let's save this as seen. And let's just say that about 30 members stands out because of a color difference and magnitude difference. Rorschach test. Norm, the cluster are next to each other, kind of touching. Is that what it's called, Stu? They're both in the red square. You think so? Almost looks like those images of populated areas on Earth at night at space. LOL, I guess we were wrong. According to the planetarium software we were, but let's hold out hope. Okay, so let's turn off deep sky image annotation here, and let's just stop the live stack and then kind of remember where that is, and let's queue up and let's watch the scope and see which way it moves. Oh, we're still in 20 seconds, so we didn't see it move fast, sadly. I should have changed to like 1 second or whatever and turn the gain way up, and then we could have seen it move. Okay, maybe just 500 gain. That's full. I don't recognize the other cluster anywhere here. Just dropped the book. Yeah, that's all said to be IC4756. I don't think it was in the same frame. Through the looking glass, there describes Alice's encounter with a fat little Tweedledum and Tweedledee. Twins' names become synonymous with any two people I see, copied from someone's astrobin. I'm gonna have to recover my book here. I dropped it on the floor. Sorry, Steve O'Meara. I don't want to desecrate your book back to 92, 93. So they are very close, just not close enough to be in this telescope's field of view, in spite of the fact that this telescope has about a 1.5 degree field of view. So that the 93, let's go down here to the title, and X93 is IC4756. So this is IC4756, the Tweedledee cluster in Ophiuchus. You know, we almost don't need to live stack this, do we? Let's just look at it like this and enjoy it, because it doesn't really need to be live stacked. Yeah, they do refer to through the looking glass. This is twice as large as the other one. They are 3 degrees apart. So see, that would never fit in our field of view because the RASA 11-inch has a 1.5 degree field of view with this camera. 3 degrees apart. 2 clusters under a tree-like asterism of stars. They're beautiful little clusters, aren't they? But, you know, a lot of people think that clusters are not worth looking at. I kind of enjoy them, though. 3 degrees from Tweedledum. Ah, the internet. Greatest invention, also the worst. Well said, Don. Beautiful cluster, twice as big as NGC 6633. This is IC 4756. And we'll just do a snapshot of this. Cool. You know, I'm liking Steve O'Meara's list of hidden treasures, and these are all objects that we would not have observed, and I don't even think they're on the Herschel list, like these two. Even though they're Herschel 400, they're not. Oh, maybe this one is. Yeah, the 93 is not, but the 92 is on the Herschel 400. So why? Maybe it's. Wonder why we hadn't observed it yet in our Herschel 400 search. You know, I bet we had. I bet we had just observed it under the name in the Herschel 400, which is weird, isn't it? It's interesting. Don says, it's fun to realize that all those stars are probably gravitationally linked. I bet the view from inside on a planet would be incredible. You're right, Don. Well, I'll be interested in knowing how these observations work. If we had seen this, we'll have to figure that out. All right, the next one, let's run this refresh again. The next one is an open cluster, NGC 6709. NGC 6709. I don't think we'll need to live stack this either. Let's go to 1 second at 600 and see if that's almost too bright of a night sky. Let's try 550 gain. Yeah, plenty. Okay, so that's showing even the color, a lot of blue stragglers in there, huh? So this is NGC 6709. NGC 6709. NGC 6709. A cluster in Aquila. How do you spell Aquila? Let's see. Aquila. Aquila. Maybe that should have been 500 after all. Now that I've seen that, that sky is showing up to be. Yeah, that's better. NGC 6709. NGC 6709. 94. That's handy. It's 92, 93, 94. 94, it's called the Flying Unicorn Cluster. What? Does that look like a flying unicorn? Oh, I bet this is the horn out here in front. You think? Stu wrote about NGC 6633, discovered in 1745 by Philippe Lloyd de Chasseau. It was independently rediscovered by Caroline Herschel in 1783 and included in her brother William's catalog as H872. Women astronomers didn't get a whole lot of credit back then. You're right, Don. Stu, it was an acceptable occupation for women, but her brother took most of the credit. Bummer. So you got these two parallelograms here. I mean, this parallelogram right here. Excuse me, I guess that's the horn. Your imagination found it. Jen, we need you to connect the dots for us, because I'm having trouble. I'm having trouble finding it. Somebody help us out here. He tells you how to find it first. And he says it was included in Thomas Webb's Celestial Objects for Common Telescopes Beautiful Wide Group. Stunning triangle of stars east-southeast of the cluster's core. I guess that would be this triangle. Think? A dim fourth companion lies to the southeast. Yeah, I bet that's it. With two parallel rows of stars extending due south like pairs of legs. Two parallel rows of stars. So here's a row. Jen, we need help. Perhaps a diving unicorn stew. Behind every great man is a woman rolling her eyes. Second conspicuous grouping is an attractive string of stars on the west side. Is that this string? Or is that this string? Or this string? Or this triangle? Boy, we're seeing a lot of these cones tonight. There are 305 plus stars in this cluster. A dim equilateral triangle of suns near the cluster's heart. The inverted V of stars immediately northwest. That's this. A sharp horn jutting from the horse's head. This. Flying unicorn. tangle of Christmas tree lights just taken out of storage. Yeah, I like that better. Doubles and tiny clusterings. Distance of 3,900 light years. Some objects don't often look like they're called. That's for sure. 12.7 light years across, 111 stars. So between 12 and 17 light years across. 315 million years old. So we're going to say about 15 light years across with 43 bright stars. So about 15 light years across with, how many did we say? 40 bright stars. Wikipedia says 141 million years old. Stu added. Thanks, Stu. You guys are great. I'm going to go back where we said 40 bright stars. And I'm going to say, and 305 plus in all. Stu. Stu is our encyclopedia. How come something still be shining at that age? 141 million years old? Must have had a big gas tank, huh, Jen? You know, it is true, 141 million years does sound old, but remember, these globular clusters, Jen, typical globular clusters are 10 to 12, the old ones are 10 to 12 billion years old. So this is lots younger than the globular clusters. Okay, we're going to refresh this and do a snapshot of this. And then let's head on over to PGC 60921, which is NGC 6503. Right, Jen. So NGC 6503 is next. And it is a galaxy, so we'll probably have to live stack this. $69.03, is that what we said? 6503. 6503. $6503, a galaxy in Draco. Draco? Is that right? Draco? A galaxy in Draco. Looks odd. Yeah, Don's telling Jen our sun is supposed to be 5 billion. Slew baby slew, JM says. This is NGC 6503. NGC 6503, Hidden Treasure 85. Draco is right. This was July 22nd, 1854. 8 years before he joined the staff at Gotha Observatory. The budding and eclectic German astronomer Arthur von Auer's discovered in NGC 6513 in Draco with his own 2.6-inch refractor. Wow. It's a dwarf spiral. Oh, there it is. Look at that. Really interesting, isn't it? So that is 20 rotations around the galaxy. And it's still producing all that heat, Jen says. Dwarf galaxy spans 30,000 light years and lies approximately 17 million light years away. I'm gonna write that down while I'm thinking of it. Good, helpful stuff, Stu. So, a dwarf galaxy spanning 30,000 light years, kind of a third the size or less, huh, of the Milky Way, and lies 17 million light years away. JM says, I get nauseous thinking about, wow. Uh-oh, the yawns. Inflation just adjusted coffee fine. JM, thank you so much. Gave another $6.50. The yawns are coming because it's after midnight. You're funny, JM. Our solar system completes one revolution every 250 million years around the Milky Way. Dawn says hydrogen, not helium. Fusion is quite powerful. The sun has lots and lots of hydrogen. I get nauseous thinking about how fast the Earth spins on axis and how fast it orbits the sun, and then how fast our galaxy orbits its center, and so on. But it will fuse helium too, then other elements, until it's mostly lead. All right, so this little dwarf galaxy a dwarf spiral seen 16 degrees edge on belongs to the Coma Sculptor cloud of galaxies located at the edge of the local void, low density hollow very small, very bright nucleus within a lens that contains bright, tightly wound spiral arms caked with dense star-forming regions. Well, it does sort of look like that, doesn't it? Let's zoom in past optical zoom until we start getting pixelation. Still not a lot of pixelation there. There, we just started getting pixelation. So that's using a little bit of digital zoom. You can see a little more of the structure of it. And we can play with this line until we think we're seeing all of the clouds. Maybe bring this in and make it a little brighter. So we can start seeing some of those stars in those outer star-forming regions. They're tough to see, but we're starting to see just a few of them. It's a lonely and mysterious galaxy. It's high surface brightness. Patches of dark and light streaks. The central pip is tack sharp, a tiny star in elliptical mist. Kind of a cool little galaxy, isn't it? I guess called a dwarf galaxy because it's smaller. Oh yeah, you're right. There is a neat little box structure here. And another one here. Two little box asterisms. It's one known satellite galaxy. Here's a hot pixel because we're using an odd dark, I bet. Let's go here and choose our correct dark. Should be 20 seconds at 100. Oh, look at that. Hot pixel remove only. What does that even mean? Is that a new thing? We'll have to try that next time. See if it gets rid of that hot pixel. All right, let's save a scene. This is a cool galaxy. Thank you, Steve O'Meara. We would have missed this. It is so beautiful, isn't it? JM thought it was a real star war in process. They now think that there are at least 1 billion Earth-type planets just in our Milky Way. The galaxy was about 1,000 up to several billion stars as compared to the Milky Way's 200 to 400 billion. So, consisting of 1,000 up to several billion stars, according to Stu. Thanks, Stu. Good stuff. All right, next up is the coat hanger cluster. And I don't see a designation for this, oddly enough. It's just called the coat hanger cluster. How can that be? How can you just call something a coat hanger? Coat hanger. It's definitely 97. So it has a X97. It's Colander 399. So we're going to say here Colander 399. And let's also make that the title. Colander 399, the coat hanger cluster in Vulpecula. Got back just in time to see the end of this scope travel settling in there. That's what all that Stu says, according to Wikipedia. I kind of like putting your name in there, Stu. Don, man, I came here to say hello and then go off to bed. I stay because of the views and the people. You're so nice, Don. Well, look, we're 10 minutes from the end. We started at 10:30, so we're only 10 minutes to the end. Oh, we've got to go to Jupiter after this. This one's old. Joan Crawford enters chat. This one's old. It was first described by the Persian astronomer Al-Sufi in his book, The Book of Fixed Stars, 964. Don, so I really can't blame you all. Whoa, look at it here in the middle. Let's back off a little bit because I don't see the coat hanger. Does anybody see the coat hanger? I don't know. Is this the top of the hook or not? Somebody help us out here. You know, I've looked at this through binoculars, and I gotta say, I found it in binoculars. Don Shakedown Cornstrom. But I don't see it here. Is this the top of the hook? And then it goes down here, and then out that wide, I guess, huh? Yes. So it goes out this wide, and that's the middle of the coat hanger. It comes up here, and then swings around like that. Oh. Is it laying on its side? Like this? I'm not seeing it. I follow the same outline, Doug. Boy. Let's go over to our planetarium software and say Colander 399. Coat hanger. They call it coat hanger 2. We could have used show chart. All right, let's see what we got here. So is this the bottom of it? I don't see a coat hanger. I see a circus tent. Yeah, I can see a circus tent. Good call, JM. Zoom out if you can. That's a full zoom. That's, oh, you're right. We can zoom out. Sorry. No, not much. That was pretty much full zoom. Going up and down. Yeah, I'm not seeing it. 6 bright stars in a line with 4 stars above it. Are you outside the Capitol building, JM? Turn 90 degrees right. I don't think we can do that while we're stacking, but we could stop stacking. Now, where is that miscellaneous controls maybe? No. Flip. So the correct flip for RASA is horizontal. We're going to put it on vertical. Not seeing any difference. Both. Horizontal. I don't think it's changing it. I guess I kind of see it now. So if you're hanging up pants, this would be the place where you'd put the pants. And then it would come up. And then I get lost. Stars are bright. You're right. Well, we'll just grab a quick save a scene. And look, there's a nice double. Look at that neat double right here. Or triple. At least visual triple. Beautiful. It's a beautiful cluster. Let's go over here and say Not sure I ever saw a convincing coat hanger, but I did figure out where the pants would hang. Some nice multiple star systems, at least they look like it. Your view is too close. Wow, JM says. Cool, Jin says. Cool. All right, now we're going to end this live stacking and we're going to go find Jupiter. So this kind of is the, this is the PS on the end of the, this kind of concludes our Omira deal. And now we'll just save this file. And then I have a little thing called Observe Next. And we'll add Jupiter to this. So we're going to say add a Jupiter lookup. Could not find the object in a database. So object type, we're going to say planet lookup. Could not find Jupiter. This is a pretty sad state of affairs if we can't say object type planet Okay, so I'll tell you what we're going to do. We're going to go over here and we're going to connect, if we can, Starry Night Pro. Connect. Sometimes it doesn't like to connect once you've used it, which is why I usually try to avoid this. Oh, it did, I think. Yeah, there's the telescope. So I think it's connected now. Yeah. And now we should be able to do this. Oh, it also crashed. Send the report. I usually send the report and just hope that someday somebody at Simulation Curriculum will wake up and say, hey guys, are you noticing we're getting like hundreds of reports from this one guy in Louisville, Kentucky? Evidently somebody's still using Starry Night Pro Plus and he likes it enough, but he's not going to like it very much longer. Leave shaders on. That's a very, very a predictable, consistent crash. When you've been using Starry Night Pro for a while and you've done several, finds, and then you try to connect your telescope to it, it crashes every time. Hello. Hello, Starry Night Pro. JM, you're very kind to encourage. JWST, picture of Neptune with rings, you're right, Stu. JM, I consider this a free lesson. Stu, you're nice. Jen says, Doug, why? Because I'm grousing about Starry Night Pro? Is that what you're getting on me about, Jen? Well, look, it won't connect. I'm kind of angry at these SimCur guys. Come on, Simulation Curriculum, can you please fix this? Sorry, Jen. Well, look. Okay, let's go back to Deep Sky while that sits there and thinks. And let's figure out why are we not... Okay, there is a thing up here you can do, and it's like a picture of a planet. Jupiter. Okay, and now let's go slew to it. So see, this was operator error in that case. I just didn't know how to find Jupiter. No, I can imagine you've sent many error notices. Yeah, you're right. I bet I've sent 200 error notices to SimCur. And 100 of them have been about that problem. I bet. I've also called them and I've gotten in touch with them, and I did a 1-hour Zoom with the guy who was very nice to me. But then they proceeded, that was a year ago, they proceeded and didn't fix the stuff that I complained about. And in that, see, it crashed again. But you guys didn't see it but here's the proof. I'm going to send the report again. In that report, look, there it is. In that report, we're a little bit off track. I wonder if we just use our manual fixer, and let's see, to go to the left, let's look again at the orientation. The scope has its weights on the right, so to go to the left, we have to go down, I think. Wrong way. We had to go up. Well, it takes usually once or twice to get the hang of that. Boy, it's a fine looking image of Jupiter now, isn't it? Yes, collectively submit a bug report. All at the same time. Out in front of their office in wherever they are, Cupertino or whatever. It's either laugh or go mad, so I'm with Jen. I'm over here laughing, not at you, Doug, but the system, right? Exactly. I did a 1 hour Zoom with the guy, and I said, okay, I'm gonna stick all these videos out there on YouTube and talk about how great your program is. Just don't make me look ridiculous, please. Fix this stuff. He said, okay, Doug. So I finally just got tired of waiting, and I'm using Deep Sky Planner now for slewing and observing. But I still think Starry Night Pro Plus is the most beautiful image of the night sky, even though we are subbing out another program to do the targeting. Yeah, those moons are popping tonight, are they? Who said that? Stu, those moons really pop, right? Now this is at 3 seconds and a gain of 300. What I find is that the moons really pop well when you end up blowing out the planet. You know, you make the moons pop well. So now let's go over to Starry Night Pro, if we can find it. Where did it go? Oh, it closed because it crashed. Those rascals. What Starry Night Pro will do for us is show us, leave shaders on, it'll show us the orientation of the moons so we can get the names of the moons. Let's pull it kind of over here out of the way. Let's get rid of this panel here. Whoops, I spoke too soon. We have to find Jupiter because we're not connected to anything since it crashed. Okay. Oh, look. There's a shadow of Amalthea. I don't think we could see that, but we'll try it in a minute. Anyway, the order is on the side where the 3 are, this would be Europa. Wait, maybe not. Yeah, this would be Callisto. So Callisto's way out there. $13. Inflation adjusted SLUware replacement tuition fund contribution. Shame. You kill me. You crack me up. SLU down. Show us, please. No image to see. You're running with the concept, James. I admire that. Awaiting your match. This is great. Okay, so this is Callisto out here on the edge. And that would be Europa, and this is Io. And on this side is Ganymede. So now you see, so again, that was Callisto, Europa, Io, and Ganymede. Now, let's zoom in some. And let's slow down the gain to like 100. And let's slow down to 1 second exposure so we stop blowing out the planet. How about 500 milliseconds? Would you believe 200 milliseconds? Would you believe 100 milliseconds? It is bright, isn't it? It is incredibly bright. Let's back off to 0 gain and go to 50 milliseconds. This is like the way we photograph the moon. Man, that is bright. 20 milliseconds. Okay, now we're starting to see some banding. 10 milliseconds. Okay, there you can see the bands. Now let's zoom in a little more till we get, now there it's starting to pixelate. But you know what? Unless that's a place on my screen, it was. I was looking for that shadow of, I was looking for that shadow of that one moon, which was Amalthea. It's supposed to be in the middle band. Right there is the red spot. Let's slow it down to about 5 milliseconds. Right here is the red spot. I don't know if you're making it out on YouTube, but it's right down here. So the moon should be up from the red spot toward the center. Yeah, we're not going to be able to make out the moon with our telescope. It's because we have a 460, I think it is, 460 millimeter focal length. And what that means is it's designed to be a it's designed to be 1.5 degrees wide. So that shows you a wider field of these clusters and stuff. But for a planet, you really want one of these like 1200 millimeter, or even, you know, there are like even higher power telescopes. You really want one of those 1200 millimeters, like your 10-inch or your 11-inch SCT that has this 1200 millimeter focal length. Then we might see that image we're talking about over here. We can make out that moon, but we're not seeing it with this. Yeah, Stu says he thinks he sees a red spot right there. Try the ROI. Astrophotography. I got to see the Comet Shoemaker created my 620. Yeah, it's a 620 millimeter on a RASA 11. Because you only spent 40,000 on your telescope, not 4 billion. Yeah, I guess so. Is that lens or entire scope swap necessary? You know, with a RASA 11, you can't really swap a lens. It's the entire scope. You'd have to have a different telescope. And, oh, I'm glad it's coming through on YouTube. Praise God. It's just millimeter focal length is all it is. You want a longer focal length for something like a planet But I'm really surprised that we are getting the giant red spot here. This is what you call like lucky imaging. 5 millisecond photos, one after another. I don't think we could live stack this. I don't think it'll work because look how much movement there is. I think it's just gonna move so much that let's clear the live stack. It's gonna move so much that I think that we're just gonna see like, yeah, exactly. Gonna see like a fuzzy shape, I believe. But let's try it. Look, those moons are coming out though, aren't they? That's wild. But look how much they're moving around. Yeah, live stacking just doesn't work on something like this because it's moving around constantly in the atmosphere. But you can definitely see the banding. Look how we can see this band. We're definitely making out that band and that band. This band here is right here with the red spot there, and this band here is right there. So it's kind of cool. I guess we'll do a snapshot. You can also shoot a video of this. China's building a 110 meter radio telescope. And to think this is live, right? Mind boggles. Green egg, where's the ham? I thought that was schmutz on my screen till it stacked again and became moons. Oh, really? Oh, I guess you're right. Because we're not seeing the moons live, are we? But that's because we've got the light dialed down low enough. I wonder if we went to 3 milliseconds what we'd see. Just gets a little bit darker then. So 5 milliseconds seems to be the sweet spot. 7 milliseconds. And that actually is not bad. A little brighter, isn't it? At 7, and then the spot jumps in and out of view with the diffraction of the atmosphere. Oh, and Don says he sees the northern and southern equatorial belts. Oh, that's what you're saying these are. The northern and the southern equatorial belt. Gotcha. JM, moons over my hammy. I don't know what that means. So this would be the North Pole, and you see how it gets darker up here? And the South Pole gets a little darker here. So let's do an observation here of Jupiter. We could make out the northern and southern, what did you call them, Don? Equatorial belts, along with the great red spot storm, but couldn't see Amalthea's shadow. What's that called? Forget. Trance something. Looks to be 3 distinct bands on my stream. 3 bands, huh? Wow. You guys are seeing it as clearly or more so than I am. So you're seeing a band here where the red spot is, and a band here, and then what? A band up here again? Or a band down here? Again, this is called lucky imaging because you just hope that one of the images is going to be lucky enough. And so what people do is they'll video this, and the images that pop into view, they'll save that image and throw away the diffused ones. And then they'll assemble all of the images that popped into view and stack those. And then you get a decent image. But that's just, again, it's called lucky imaging. Shooting a video. Did you know around the poles there are 6 or 7 vortex storms? No, but they're showing up in, definitely showing up in Starry Night Pro Plus here. See all those storms here. Move this over here. So obviously, it goes without saying, I'll say it for, anybody watching the video, this image on the right is a planetarium software. The image on the left is real time, out in this, observatory with this telescope right now, real time, looking at Jupiter. The night before it comes closest to the Earth, in the last 63 years, or whatever you guys said. Very similar in size. It's a trip. Saw a lucky imaging video the other day of 30,000 images. It kept 6. That's what these cell phones these days are doing, computational photography. Just focus. Well, you guys have been great. Thanks so much for making this a part of your night. You're so kind because, remember, I'm an explorer with you, not a guide, and you guys are so kind to explore with me, and you participate in this, and it makes it so much more fun that if I was just sitting out there at the scope, huddled around on one little eyepiece, hoping against hope that if I avert my vision, I'll see something. Instead, we get this kind of like, I don't know, it's almost like we're together in a synergistic way, trying to make sense out of all this stuff that really we just are trying to just barely see the glimpses of from light years sometimes away. Thank you, God, for making all this stuff. It's beautiful. Thanks for letting us see it tonight through this telescope. And thank you all for the way you participated in being a part of this. And thanks for those who pitched in. You're kind, Stu, to call it a pilot, but I feel like I'm a fellow explorer with you. Jen, you're kind. JM, thank you for jumping in there. You really participated well. And we'll look forward to seeing you guys the next time. And this is it from Emerald Hill Skies. We'll look forward to seeing you next time. God bless and good night.